So, further mathematicians, this is exercise 6D, solving more hyperbolic equations. Let's get started. The first type is where you have so many sine plus so many cos equals a number. Now, this is a very specific number. This is when it's equal to 0. So I'm going to start off on this occasion. I'm going to write 7 sine x. Now I'm going to move the 3 cos over immediately onto the other side. So equals minus 3 cos x. And I'm going to move the cos that way, and I'm going to move the 7 that way. I get sine over the cos equals minus 3/7. And the reason why I do that, that means that tan x is minus 3/7. And that means I can find x by taking an inverse tan. Move the tan over, it becomes inverse tan of minus 3/7. Now I could type this into my calculator, but it does ask for an exact logarithmic equation. So I get that from down here, or from the formula book you get all these, so that gives me a half of the log. And type it into your calculator, 1 plus minus 3/7 divided by 1 minus 3/7 gives you 2/5. I just did it on the calculator, so that gives me a half log 2/5. So there it is. So just type it in and you get the answer. Next one, now it's exactly the same left hand side, but now it's a different right hand side, and it makes all the difference. So if I'm going to solve this, I have to go back to exponentials. And this then is, you should remember that sine is a half of some exponential formula. So I'm going to write that as 7 over 2, and I'm going to write e to the x plus, minus e to the minus x. It's sine first on this one. And then it says plus 3 cos, so that's plus 3 over 2 e over e to the x plus e to the minus x. So get your head around those. Equals 9. So I basically collect up all my e to the x terms. I've got 7 halves plus 3 halves, that's 10 halves, which is 5. And I collect together all my minus e to the x, e to minus x terms. I've got 7 over 2 of the minus plus 3 over 2. I reckon that's minus 4 over 2, which is that right? Minus 2e to the minus x. That's right. 7 halves minus 3 halves is 4 halves. Yes, that's right. Equals 9. Now the trick here is to spot it's a disguised quadratic. So I might as well times everything by e to the x. That's the standard way of doing it. Give me 5e to the 2x minus 2. The e to the x's and e to the minus x's cancel out. 9 to the x. Move this over here. I get 5e to the 2x minus 9e to the x minus 2 equals 0. And this is a disguised quadratic, as I said. So I'm going to type this into my calculator. And when I type it in, it's menu A, then polynomial degree 2. So that's 5, then minus 9, and then minus 2. And I get, well, it says x1 is 2, so I know that I use the middle thing here. So e to the x equals 2 is one possible solution. And the other one, all right, the other one is negative. And the reason why I say oh is because you can't have e to the x equal to a negative number. So this gives no solutions. And we'll write that properly if we come to an exam question. But this is just x equals log 2. And that's, according to me, the only solution. There it is. Next question there. Well, just looking at it, it's very, very similar. So I've got so many cos, so many sine equals, no, it's not 0. If it was 0, I'd use that first trick I had. But because it's equal to 7, I have to do this in an exponential form. So it starts with a cos, so that's 3 over 2 e to the x plus e to the minus x. Minus 4 over 2 sine, so that's e to the x minus e to the minus x equals 7. So that's, collect my e to the x's. I've got 3 over 2 minus 4 over 2. I reckon that's minus a half e to the x. And I've got 3 over 2 minus and minus, so that's plus 4 over 2. That's 7 over 2 e to the minus x. And that's equal to 7. Now, I could type that in, but I'm going to actually times everything here by minus 2e to the x this time. And times it by minus 2 will just make this slightly tidier. It will give me e to the 2x minus 7e, no, that will disappear, equals minus 14 e to the x. There you go. Make sure you get your head around all of that. Move everything onto one side again. Plus 14 e to the x minus 7 equals 0. Go back into my calculator. It's still on my screen actually. That makes it a bit easier for me. I've got one of those, I've got 14 of those, and I've got negative 7. And it says x1, and therefore e to the x equals minus 7 plus 2 root 14. And the other answer, oh, it's minus 7 minus 2 root 14, which will be negative. So I'm going to write it as minus 7 minus 2 root 14. But then underneath, if this is an exam question, I'd write something along the lines of that, making sure I get exactly what the exam board want me to write. Move the e onto the other side, get a logarithm, so it's minus 7 plus 2 root 14. See what the answer is? Well, they've just written it the other way around, but yes, you get the idea. Oh, this one's got the answer already, but we'll see if we can get to it. Oh, right, it's a cos squared one this time, and a sine. So this is one of the ones. We're going to use this formula down here. Now, this formula allows me to write cos squared then as 1 plus sine squared. Plus the 1 equals 3 sine x. And this effectively is the disguised quadratic again. So all onto one side, sine squared x minus 3 sine x plus 2 equals 0. Again, it's still on the screen, so let's do it. So I've got 1 sine squared, I've got negative 3, and I've got 2. And it says x1 is 2, so that tells me that my middle term again is sine x equals 2. Or sine x equals 1. Now again, I could type this into my calculator using the button and get me an answer. I says, well, my answer is in exact form here. It doesn't say, oh, you know, it does say in logarithmic form. So to do this, I'm going to use this expression. So x is the inverse sine of that, so it's a log, and it says x plus, so that's 2 plus the square root of x squared plus 1. So I reckon that's root 5, and I do it. Or x equals, and again it's the log of 1 plus root of x squared plus 1, that's 1 squared plus 1, that's root 2. And that's what we've got down there, so that's worked quite nicely. Right, now this is asking about stationary points. Stationary points, I mean, we're not doing differentiation properly, and this will require us to do differentiation. But one thing I should say to you, if I have a function, and I'll write it here as y in the little table, I'll write dy by the x here. So if you start with your function and it says sine, differentiate it and you get cos. And nicely, if you start with cos, you get sine. We can prove that later on, but for now I'll need just to know that. So it says, it's given that f of x is this, find its stationary point. So I'll do that for you now. We do that by differentiation, dy by the x, or f dash of x in this case. It says 2 sine, so that becomes 2 cos. And it says 3 cos, so that becomes 3 sine. And you should remember that you find stationary points by setting f dash equal to 0. That's the trick. So I've got to solve this equation if I'm going to find where the stationary point is. So I shall write 2 cos x. You'll notice this is equal to 0, and the starter was very much like this. When it's equal to 0, you move that over there. Minus 3 sine x. And then I can move the minus 3 that way and the cos this way, and I get minus 2/3 equals sine divided by cos, which is tan. So x then is the inverse tan, and I'm going to do that using this formula again. And it's a half of the log of 1 plus minus 2/3. What's that? So that's 1 plus, so that's a third divided by 1 minus minus, so that's 5/3. So this is a half of the log of a fifth. Now it's not quite what they've got here actually, they've got a minus. So just bear in mind that this then becomes a half of the log of 5 to the minus 1. That's what a fifth is. And the power then can come to the front, and that gives me a minus a half of log 5, which is what they wanted. It does say find then the value of y at this point. So if I'm going to find the value of y at this point, what I've got to do is effectively go back to this. This is my y, and I've got to sub it in. So I'm going to write y equals, excuse my lack of room here, y equals, what is it? It's 2 sine of minus a fifth. Minus a half of log 5, sorry, plus 3 cosh of minus a half of log 5. So I suppose it would help if I find out what sine of this thing is and what cosh of this thing is. And you know what, you could cheat a bit here. I'm not sure if it might come out to be a nice answer. I'm half tempted to type it in. Let's type, I mean, if it doesn't give me a nice answer, I'm going to have to do this properly. So menu 1, I'm now going to press the option and the hyperbolic function, and it says shine. So yes, so I want to press that. I want the shine of minus a half log 5. So I'm typing that in now. If it gives me a nice answer, I'm sorted. No, it doesn't give me a nice answer. That's typical, isn't it? So in which case then I'm going to have to do this properly, and I'm just going to write shine of minus a half log 5. Now it's worth noting that this thing is a half of e to the x, so that's a minus a half log 5, minus a half of e to the minus a half. Oh, but that becomes a half log 5 because the minus a minus. So this one is easier because the half can move up. That becomes like 5 to the half, and the e's cancel. So this is minus a half root 5, and this one is a half. Well, it's exactly the same, apart from the mic goes up, and then it becomes a half of the square root of a fifth. So I've got 2 of those. I'm going to have to bear that in mind in a bit. When I do the cosh of all of this, minus a half log 5, that becomes a half of e to the minus a half log 5 plus a half of e to the minus a half log minus and minus. There, I'm getting there. Eventually getting there. So again, I think it's the same trick. It's a half root a fifth minus, now plus a half root 5. Now I'm guessing these can be simplified. What have we got in the? Oh, right, they've done all that, and they've come up with shine x equals that, cosh x equals that, and then obviously when you chuck it into your calculator, into the original function, we need 2 of the shines, 3 of the coshes, and they've got root 5. I've done that because I'm running out of time a bit. And the last thing says solve the equation f of x equals 5, and that looks the same thing as we were doing playing around with just now. So that's no different. The only real different bit we've seen on this is this differentiation stuff, and then quite a tricky chucking the y, values in to find y. So make sure you have a look at that. Have a go at the part 2. There's the answer to part 2. So that will hopefully, we've seen a number of those examples now, and you'll be able to follow that solution through and get those answers, and hopefully they'll work out nicely. And then your job is to have a look at exercise 60. Exercise 60, more of the same. So best of luck with those, and we'll continue with this soon. All the best.